Atomic discoveries are the historical experiments that help lead us to the knowledge of the atom that we have today. The first person that's ever on the radar of chemistry and history is the ancient Greek philosopher Democritus. Democritus is old, 450 BC. That's a really, really long time ago. That's over 2,000, like we're getting towards 2,050 years ago, or sorry, 2,500 years ago. So, Democritus was a friend of Aristotle. You might have heard about Aristotle in some of your history classes. Aristotle thought Democritus was crazy. In fact, Aristotle wanted all of Democritus' books burned. Why? Democritus had this crazy idea. Democritus said that all matter is made of tiny invisible particles. Nobody believed him. They thought it was foolishness that to look at something like a piece of paper and to think that that piece of paper was made out of tiny, invisible, how convenient, invisible, you can't see them, particles. The problem is that we're not learning about Aristotle in this course. We're learning about Democritus because Democritus ended up being correct. So he is one of what we call one of the fathers of chemistry. And in Greek, he came up with this idea of atomos. And so we credit him as being one of the first people to think of the concept of the atom. The next person on our radar for the history of the atom is John Dalton. John Dalton was from England. He was a philosopher. He also did lots of experiments about gases and the properties of gases. He came up with what is called the atomic theory. Notice the date. The date is 1803. This is over 2,000 years from when Democritus first came up with his idea of atomos, or that all matter is made of tiny particles. John Dalton took that theory and instead made it a little bit more detailed. He had several points. The first one is that all elements are made of atoms. He was correct. So even though he didn't know this through experimentation, he had this as part of his theory and he was correct. Number two, all atoms of an element are identical. That means that one carbon atom is exactly identical to another carbon atom, which is exactly identical to another carbon atom. For the most part, he was also correct. There is the concept of an isotope that we'll learn about a little bit later, where it's not quite right on par with what he said, but pretty darn close. The third part we're going to talk about is that atoms are not created or destroyed. In general, he was correct for that too. He also talked about the atom, whether it could be split or not. We found out with the era of nuclear chemistry that we can split an atom, its nuclei, but for the most part, atoms can change into different types of elements, but in general, their mass is not created or destroyed. You'll learn more about that physics where we start talking in physics where we talk about energy coming to play a part. He also came up with what we call as the solid sphere model of the atom, or in other words, the atom is this nice round little blob and we don't really know what's inside of it.